I'm going to talk about arcs, circumferences, and areas of circles. I'll assume that you know the basics of circles, such as what a circle is, what a radius is, and what a diameter is. If any of that is unknown, I would invite you to watch my video that introduces the topic of circles. All right? Now, let's continue. Let me now define what arcs are. All right, so I've drawn a picture of a circle, and so an arc is nothing more than a piece of a circle. Okay, so let me highlight a piece of this circle in blue. Okay, so that is an example of an arc. Let me highlight a different piece in green. That is another example of an arc for the same circle. So as you can see, arcs can be different sizes. Okay, let me make a smaller arc by highlighting a piece in purple. Now, what if you wanted to compare arcs to see if two arcs were congruent, or if one of them was bigger? Okay, to see which one was smaller, bigger. What you can do is you could certainly measure the lengths of the arcs. You can also measure the corresponding central angles. So remember that central angles are angles with their vertices at the centers of circles. Okay? So to compare the sizes of the blue, green, and purple arcs, compare those central angles. Now, what if you wanted to compare two arcs with respect to two circles? Okay, well, you can do that. If the arcs are congruent, then the circles will be congruent. Okay? And we know that circles are congruent if the radii of the two circles are congruent. All right, so if we wanted to know, for example, if those two purple arcs on those two different circles were congruent, okay, we can confirm that the radii are the same, and we could measure the corresponding central angles. So let's say that both radii had both circles had a radii of 2. Okay, so then the circles are for sure congruent. And let's say that the corresponding central angle, both corresponding central angles had a measure of 10 degrees. Then we could know for certain that those two arcs are congruent. Okay? Now, let me talk about circumferences. So a circumference is the length of the length you'd have to walk around an entire circle. Okay? Notice that the circumference is the length of an arc, the arc that contains the entire circle. Okay? I'd like to talk about a property of circles that will lead to a formula to calculate circumferences. All right, let me draw two circles, and let me denote the circumference of the big circle by C1, and let me denote the circumference of the little circle by C2. Let me further denote the diameter of the big circle by D1, and let me denote the diameter of the little circle by D2. Okay, now you can confirm this. You can draw circles all day long of whatever size you like, and measure the diameter of your circles with a ruler. Somehow try to approximate the circumferences of your circles, and you will notice the following interesting result. No matter what circle you work with, the ratio of the circumference to the diameter will be the same. Okay, so if I measured C1 and D1, found their ratio, that would be equal to what I would get if I measured C2 and D2 and found their ratio. All right. In fact, there's a name for this ratio that shows up for every circle in the universe. It's often denoted by the Greek letter pi. Okay, so that gives us a formula then to calculate the circumference of any circle. If you, in these two purple formulas, if you multiply both sides by the corresponding denominator, what do you get? You get C1 is equal to pi d1 for the big circle, and C2 is equal to pi d2 for the little circle. Okay? So for any circle, the circumference, if we call it C, is equal to pi, which is a number that I haven't stated yet, but it's whatever number is represented by the Greek letter pi, multiplied by the diameter, let's denote it by d, okay? That is the circumference. Now we know that the diameter is equal to twice the radius, so we can also write this formula as 2 pi r. Okay, and that will be our formula for the circumference of any circle. All right, so now you ask, so what is the number that is associated with pi? You could measure the diameter and the circumference of a circle and get an approximation yourself. People, of course, have done this through the centuries. And so I'll go ahead and tell you an approximate decimal. Now, it's a decimal that never ends, but I'll give you just a piece of it, an approximation to it. So pi is approximately equal to 3.14. Now, sometimes people, for various reasons, memorize more digits. I happen to know it's equal to 3.141592653. People have memorized more digits than me. Some people have even memorized thousands of digits of pi. Okay? Now, let's do some examples using this formula. Suppose I had a circle with a radius of 4 meters. What is the circumference? Well, the circumference is equal to 2 pi r. So 2 times pi times 4, that gives 8 pi meters. Okay? You can multiply 8 by 3.14 on your calculator. That'll give you a number slightly larger than 24. Okay? Let's do another example. What about if somebody told you that a circle had a diameter of 11 feet? Could you determine the circumference of that circle? Why don't you pause the video and try to work that out now, if you like. Okay, so I'll go ahead and work it out as well. So now I'll use the formula pi d. So the circumference is 11 pi feet. If you like, you can get a decimal. Something a little bit over 33 feet will be the answer. All right. Now, the circumference formula is actually going to give us a way to measure the lengths of arcs. Let me show you how. Suppose we had a circle, and suppose the circle had a radius r, and suppose we had a an arc and its corresponding central angle, and let's say the central angle has a measure of theta, and let's say the arc has a length s. Okay, and we want to know what s is. All right, so to find out what s is, we will use the following observation. And let me highlight the arc s, the arc with the length s in blue. All right, so the arc, I think you would agree that the arc takes up a portion. The length of the arc is some fraction of the circumference, right? And the corresponding central angle measure is a fraction of the angle with respect to the full circle, or 360 degrees. Okay? Hopefully, a moment's thought will make you see that those ratios are the same. So in other words, theta over 360, the fraction of the entire circle, okay, that corresponds to theta, that's equal to the fraction of the theta over 360 degrees is equal to the fraction that the arc takes up of the whole circumference. So that's equal to s over 2 pi r. See that? All right. So now we can solve for s. Let's multiply both sides by 2 pi r. So we get that s is equal to theta over 360 degrees, the fraction of the angle of the entire circle, multiplied by the circumference. Okay, so that's a handy formula to remember. All right, let's do an example using this formula. So suppose that I had a circle with a radius of 3 and suppose that I had an arc with a corresponding central angle that was 180 degrees. All right, so what is the length of the arc, the corresponding arc? I will highlight it in blue. All right, so to calculate that, I would use my formula. So 180 degrees divided by 360 degrees, that's equal to 1/2. So 1/2 of the circumference is going to be what the length of the arc is. So that will give 3 pi. Okay? So there you have it. Now, let me have you do an example. Suppose that I had a circle with a radius of 10, and I wanted to know the length of an arc on that circle with a corresponding central angle measure of 90 degrees. All right, pause the video and try to calculate that arc length, please. Okay, so I'll go ahead and do it. So theta over 360 degrees times 2 pi r. So 90 degrees over 360 degrees, that's a quarter, times 2 pi times 10. So a quarter of 20 pi is 5 pi. All right, so now let's talk about the areas of circles. suppose we wanted to calculate the area of the circle that I've just drawn, and let's say that the radius of this circle is r. Now, you hopefully know that I can chop the circle into pieces, and I could measure the areas of all those pieces and sum up those areas, and that'll still equal the area of the original circle. Okay, so that's what we're going to do. Let's chop up this circle into several pieces like I'm drawing. This might make you think of pizza slices. All right, so I'm chopping up the circle into several pizza slice shaped pieces. Okay, now, and let's assume that I cut it up in such a way that all those pieces are congruent. Okay, now I can rearrange those pieces as follows. I can put one pizza slice shaped piece like this, and then I can put another one right next to it like this, and another one. Okay, so I can arrange it like this. Now, it might not seem like this is accomplishing anything, but just bear with me. All right, let's see. So I have a 2, 4, 6, 8, 2, 4, 6. I need to do 2 more. All right, now if I chopped up the circle into more and more congruent pizza-shaped slices, the sizes would get smaller and the quantity of pizza-shaped figures would increase. Okay, if you kept making them smaller and smaller, extremely small, you would notice that when you lined them up in a similar way to how I lined up my 8 pizza-shaped slices there, you would get something that was getting closer and closer to a rectangle. Okay, why is that? Because all of the pizza slices would be like toothpicks. Okay, so if I could draw lots of very tiny pizza slices, it would look something like this. Okay, so you'd have all these tiny toothpick-shaped pizza slices, and when you combined them, it would form a rectangle shape. Okay, now what are the dimensions of that rectangle? Okay, well, we know that the original circle has a length equal to 2 pi r, and that's the circumference. Let me denote that by c. Okay, and we know that the circumference corresponds, if you think about pizza slices, the circumference corresponds to the length of all the pizza crusts. Okay, notice that the top of the rectangle has half of the pizza crusts, and the bottom of the rectangle corresponds to another half of the pizza crust length. The reason is because of the way that I've laid out the pizza slices. Okay, now, so that means that the longest side has a length equal to half the circumference. Okay, now what is the short side length of that rectangle? Okay, well, can you see that as the pizza-shaped slices get smaller and smaller, that the length of the short side length of the rectangles is getting closer and closer to r, the radius of the circle? All right, so therefore, to calculate the area of the circle, we can find the area of the rectangle, which is much easier. The area of a rectangle is the area of the base times height, length times width, whatever you call it. So if we denote the area by A, that's equal to r times half the circumference. But we know that the circumference is equal to 2 pi r. So if we divide 2 pi r by 2, what do we get? We get, well, the 2's cancel. Okay, so then we have a pi and we have 2 r's left, don't we? So pi times r squared. Okay, that is the formula for the area of a circle. And you're going to want to remember that. Okay? Now, let me use that in an example. Suppose I had a circle with a radius of 2 centimeters, and I wanted to find the area. So I'll use my formula, pi r squared. So pi times 2 squared, or 4 pi squared centimeters. All right. What about if the diameter was 20 miles? All right. Well, I'll use the same formula, area equals pi r squared, and the radius is half the diameter. And I want to square d over 2 if d is the diameter. So that'll give pi times 10 squared, or 100 pi square miles. All right. Now I'd like you to do some examples. Suppose I had a circle with a diameter of 10 meters. I want you to find the circumference, the area, and an arc length of an arc with a central angle having a corresponding central angle having a measure of 60 degrees. Okay, so pause the video and do that now if you can. Okay, so I'll go ahead and work it out myself. So the circumference can be denoted, or can be calculated by finding pi d. So 10 pi meters takes care of that one. And the area is pi r squared, or pi times d over 2 squared, which gives pi times 10 over 2 squared, 5 squared, that's 25 times pi, 25 pi meters squared. And then for the arc length, if the corresponding central angle has a measure of 60 degrees, 60 over 360 is a sixth, 1/6. Okay, so we're going to have to find 1/6 of the circumference. The circumference is 10 pi. So 10 pi over 6, or 5 pi over 3 meters. All right. Now, I'd like you to do one more. Suppose I had a circle for which it was known that the circumference was 300 pi feet. Could you tell me, just using that measurement, could you tell me what the diameter was and what the area of that circle was, and also the length of an arc that had a corresponding central angle measure of 10 degrees. Okay, so pause the video and work that one out, please, if you can. Okay, so I'll go ahead and do the same as well. So circumference is equal to pi d. So d is circumference divided by pi, which gives 300 feet. Now the area is pi r squared, or pi times the square of d over 2, which we just calculated. So pi times 300 over 2 squared, so 150 squared times pi. Let's see, we can even work that out. Let's see, so that's 150 is 15 times 10. So 15 squared is 225 times 100 gives 22,500. So we'll go with that, pi square feet. All right.